Hi, hello sir. My name is Bandi Anodhukumar Reddy and I recently graduated from Veltech Rangarajan, Dr. Sekuntala R&D Institute of Science and Technology in the stream of Computer Science and Design, AIML. So during my college academic in the major project, I have done an industry interaction project that is an gearbox machine shop efficiency improvement system using data analytics. So that is the my project title, and in this I wanted to discuss about the problem statement. So basically, we need to eliminate all the frequent stocks due to the lack of matched sets. In that matched set, there will be consisting of an main shaft and lay shaft and input shafts, and then six main shafts, and also the five lay shafts and one synchronous pack. Totally, there are 26 number of parts in the one set. Then that can be called it as a major set. If one part is also less, no, then there will be a lack on this production. That is the main problem in this. So we need to find out that and we need to rectify that. And also we need to plan the production has been the arrived at the all the parts are not. We need to make it the changes. Like we need to make sure that before going to production. So we need to find all those, and also we need to check up all the inventories setup changes, like all the parts are there or not there. So we need to set up, and also we have developed an one of the UI system. So I will show you in later. And also we were used the backend as the Python technologies, and in the for storing the all the data, we are used in Firebase, uh, Firebase, and also here they have given some of the constraints like to develop the system by using this MX Excel and Power BI and Power App. But we have used by using this MS Excel, but we not used in this Power BI. So instead of Power App, we used an Streamlit, Streamlit. So that is the thing. So this is what the problem statement is. For this problem statement, so basically they have given some of the data sets, like what is lay shafts, and then main shaft gate soft, and then main shaft soft and lay shaft soft. There are capacity of these many parts are should be readily available before going to the production state. And also I visited the Ashok Leyland plant in Annur. So in there are three godowns are there. One is an heating stage, and then softening stage, and then roughening stage. So these three godowns are very very big godowns. What under all they were do know. See in this roughening stage and all, and then softening stage all, softening stage and all, and then heating. Heating is what are all the raw materials are there, no? Based on that raw materials, they are making the shapes of that gearboxes. So that is then the roughening. Then what is softening phase, no? In that softening phase, it mainly they are mainly focusing on the polishing of the raw materials. So that is an softening phase. Okay, so that is the thing here. And what are all the deliverables? What there before going to what UI we should made, no? The user will upload the Excel sheet. Based upon the Excel sheet, it will process the data, and it will shows how many gearboxes should need to produce. That type of things we have developed in that UI. So now I will go through with this one of the slide how we approached those things and all. I will explain now. So this is the workflow about. This is actually the we have some of the plans, like a master's plan, and then there are mainly we divided into in four parts. That is an masters and monthly inputs and weekly inputs and daily inputs. Okay, in this master's plan, we have mainly again it will be having a gearbox assembly and its child parts of matrix, and also it will be having an shift output master plan. Master is also there. In that master, we have and so five colors are there. I will show you in the UA. Based on that UA, it will be very high. And then heat treatment. I said no in previous one of the heating process is there. That process will be having an batch size master. This is a batch size master, and also VFJ gearbox production master is also there. These are all comes and also alternative child part master is there. These masters are all this comes under as a master part. And the monthly inputs, see basically we need to predict, and the main problem of this the Ashok Leyland in the gearbox mission shop, they are following the manual data entry. But what we made, like the user, the employee may can upload the Excel sheet. Based upon that Excel sheet, it will process the data and it will show the dynamically production of that gearbox parts. How many parts need to, like I need to produce this today or tomorrow, or it may be this week, or it may be a next week, or it may be a day, upcoming 2 weeks, or and also the main project, the main aim of this project, to predict the production plots for up to 3 months. That is the main motto of this project. So this is the thing. And it comes to this weekly inputs, I said no, weekly MPS plan is also there. And also daily inputs, how the gearbox assembly production is going on. Based upon that, we need to predict that gearbox parts, and we need to based upon the assembly parts, and we need to see the how many parts are required. So based upon how many parts are required, how many parts need to produce, that is the main thing. And also daily gearbox child parts inventory without a parent child. See, if one child part is also missed, the gearbox entire production will be down. So that is also one of the drawback of these things. And also comes to daily tentative, coming to daily tentative plan. See basically some of the gearbox parts are required, so most important. Some of them are not important. See, let's take an example like one ID gearbox, like PAA011A is main important. But I need this child part 20 PAA0110. This part is main important for today's, means that parts are required for today's. But if I don't want that part to, I mean today, means I can produce that part for tomorrow, or maybe a day after tomorrow. So that is the main thing, that tentative, based upon tentative plan, the plan has been changed. So that is the main thing. This workflow, this is an workflow diagram. Now I will show about what we have developed an UI, user interface. This is a basic demo video. What I am showing is, behind this a lot of things are available. So if I explain you, it may takes a more than 2.5 hours or three hours. So if I go technically, so what we developed, this is an basically a dashboard we have developed in it. In this is a navigation bar. In this navigation bar, I have given a menu as a dashboard. So if you're clicking this dashboard, it will gives the all the functionalities. Here we have some of the functionalities, like additional calculations. Here you are seeing, right? Wait. Yeah. Now you are seeing, right? This is an additional calculations, monthly GP requirement after OS. What are all the parts I need to produce? That means after opening stack. And also what are all the gearbox parts I need to what are all the gearbox parts are required for this balance month. And also how many parts I need to how many parts I need to produce for this day, or for this tomorrow, or maybe a day after tomorrow, or it may be a month, or this month, or maybe a next month, or for this upcoming 3 months. Like that, there will be having and some of the additional calculations, and also a priority sheet. Once if I go through this calculations, I will show how this will be looks like. Okay, these are the additional calculations. So we have given an in this choose a functionality, we have given an three drop down menus, like additional calculations, and then one of the matched set. This matched set is like how they are based upon. See, actually we are producing daily 12 parts, means based upon the child parts, how many are there. That means matched set means 20, like I said, no, 21 parts should be readily available before going to this production part. Here, like you can see here, wait, this 26 parts should be readily available before going to an production stage. That is very important. And also one synchronous pack should be readily available. Without this, the production won't be goes. Okay. And Yes. Next, this is a functionality of this matched set. In this matched set, uh, we have an three things, three functionalities against tentative plan and against MPS 2 weeks tentative plan and against MPS 4 weeks tentative plan. And also we have an one of the drop down menu has a norms master. In this norms master, this is a final stage in our project. This norms master basically what it will do, so it will have some of the colors like like 6 colors. Mainly it will be having an white and green and yellow, and then norms red and then norms black. These are all the 6 colors are very important. Why we are making this? This can be called it as a color grading. Also, we can call it as color grading. In this, this is a last step. Basically, how the process will be 0 to 0.1 means this will be process very high priority. Then 1 to 256, there will be having and some benchmark. Based upon that benchmark, we need to produce those parts. So those things will be given here in this six color grading. Based upon this color grading only, they need to produce the gearbox parts. So now I will give a just basic demo on this, how the calculations are going on those things. This is an UI. The employee will know upload the Excel sheet from these things. And also we have given the maximum limit up to 200 MB per that file. Okay, this is one of the validation here. We were written here. And also the user can click on this browser files. Once the user is clicking on this browser file, then it will goes to that data. That means um, what the data set, or they have given they already uh, following the manual, no. So the main aim of this project, I said in the previous, like they are following a manual data entry, but this UI makes no dynamic data. That means dynamic data means already they have given the manual data entry. Based upon that manual data entry, it will predict the how many productions. That means how many gearbox parts need to produce this month, or maybe next month, or maybe upcoming month, or up to the 3 months, or up to a week, up to a 2 week, up to a 3 week. That means based upon the plan. Okay, this is an basically how the Ashok Leyland that my team lead given my team lead given as these data sets to train to test the UI. Okay, based up that whether the UI is working properly or not by uploading these data sheets, like that they have given. So I am uploading this data sheet in this data flow. In this data flow there are 6 sheets are there. Okay, okay. First you can comes to this additional calculations in month GB requirement after OS. In this monthly GB requirement after OS, no, monthly gearbox requirement after opening stock, it may consist of up to 3 weeks. That means 3 months, sorry, like from starting from March and April and February, it will predict up to 3 months. Based upon this, if I don't want this March and all, then automatically see, based up how this March, April and February comes, no. Here in this Excel sheet, there are having that months from March, April and then May. Again, it may comes like uh, um, May, June, and July. Like that, it will goes on, and then August, September, and November. Like that, it may goes on up to three months. Like that, it may goes on. Now, if you are seeing this calculated result, it may calculating the results how the opening stocks are there. Based upon that opening stock, how many how many parts I need to produce per week. Per in the March month, or the in every in every month there will be having an 4 weeks, right? Based upon that 4 weeks, which priority I need. Here there will be having a gearbox parts. I said in earlier, this is a gearbox parts. Based on that priority gearbox part ID, that priority ID, we need to produce that gearbox parts. Based upon that only, it will be going. Okay, this is our main thing. And also we have given one of the features. These are all the opening stocks, and these are the month. That means how many parts I need to produce for March week 1 and March week 2 and March week 3 and March week 4. Like that, we have calculated in the backend calculations. and we have given the one of the feature. Once the calculations has been done, no, the employee can directly download that processed Excel sheet once the entire thing is gone. Now I am clicking on that this processed Excel sheet, right? Once if I am clicking this processed Excel sheet, it automatically it will downloads, and the employee can see this Excel sheet. It will be easy process. So this is like one of the sheet here. So see the automatically it will download so based upon the processed Excel sheet. Okay. Okay, and this gearbox requirement after balance month, no? This is also very similar to the same thing, but totally how many parts are there based upon the total parts. These are all the total openings after means the a gearbox required for balance month means, and then means for balance month like upcoming month or maybe upcoming month based upon this. Let's take an example for this total how many gearbox parts are there. A5P64100. If you take this gearbox part id, it will be total having and 20 parts are there. Okay, so based upon the demand for week 2, how many I need to produce? 8 I need to produce, and in this week 4 I need to produce 12. After completion of this 12 plus 8 is nothing but 20. This is the total parts I need to produce. Based on that plan only we need to produce it. Okay, and then week 2 excess. This is also how many excess are there, because some of them are may excess it may come. It will gives the negative values over here. Okay, so same kind of thing, we have given one more feature to download this processed Excel sheet. Again here for every functionality we were given the download processed Excel sheet button over here. So this is the thing, and made here part calculation is also there. Once the made part based upon that selected date, no, how many parts are made today. See, basically in the plant, the people who are all making the parts now, if I tell to that person, the vendor, hey, please make 100 parts today, means they won't make 100 parts by one day itself. Why means, if you take in morning, they may start by early morning by 9 o'clock. By starting itself by starting 9 o'clock, it may directly they won't start, because of they need to check the entire the missions whether the mission is working properly or not. Again they may goes to some break times, and again they may in afternoon times they may go lunch breaks. So these are all the things will be there. I said a vendor, can you make 100 parts today, but they are making 90 parts per day. Then excess how many are there? Remaining 10 parts should to prepare those parts for next production. That is the main problem. So based upon that date and the time, date, no, they can select that part. How many parts are how many parts are made today. Like that they can see. Base like you can see here like made here gearbox child parts. Like if you can choose F8A 04011 ID. In this first on MS, this first on MS means like a first on main shaft, there will be having a 0. That means there is no demand on this here. Whether 0 and 1 means whether is a demand or not demand. Whether this child part has to produce, this child part has to manufacture, need to produce or not produce, or manufacture or not manufacture. Like that they are given this 0 and 1. So this is the main thing, and comes to this priority sheet. This priority sheet, whether this softening stage and heating stage and roughening stage, these three stages, which one is the priority, most priority, in which phase the priority has been comes more. Based upon that priority wise, we are making the gearbox parts in the advanced manner. By making this advanced manner, it may goes the production very smoothly. So that is the main thing in this priority sheet. And in this matched set comes to this coming to this matched set, this is an against a tentative plan. So there will be having some of the without in this tentative plan without alternatives and with alternatives. First coming to this without alternatives, the total, you know the total with the alternatives and without alternatives, the total minimum shaft, the total should be 113. Okay, these things will be very important. Whether the production is going on, whether the production is not going on, the alternatives and without alternative should be 113 only, both for against your tentative plan and MPS 2 weeks plan. In this MPS 2 weeks plan also, no, with the alternative and without alternative, the total parts will be there, no, 113 only. That all the current MH and then sub 2 on main shaft MS. Okay, for these things. And 4 weeks tentative plan also, no, for this also same things. So now you are seeing, right, in this like you can take the 69th, okay, 69th specification. The specification is A5P72900. We have an V4 revised week 4 is 204. From that, minimum current MH value is 134. Based upon this 134, how many first NMS child parts are there, how many second NMS first child parts are there, we need to check it, and we need to, according to that, we need to manufacture the parts. So this is the main thing in this 4 week plan alternative and 4 week plan without alternative. So now comes to this norms master. This is a norms master. This is a last functionality in this UI, this norms master. In this norms master, basically this red, we have in 6 colors like white, green, yellow, red, black. White means it will be having, and the value has 0 to 1. It will be a almost, it will be like a completed manner. And then green means there will be a production is going on, that parts are all very urgent required. So, and then comes to yellow. In this yellow, no, the yellow value should be in between this 60, and then in between 60 and then 0, there will be in between those productions, means those production parts, means it will be comes under as an yellow part. If it is more than 64, no, then that way, if that the gearbox parts under all are not required for this week, or for this next week, or for the upcoming up to 3 weeks, like up to 1 month. This is a norms red, and in this norms red, no, sorry, in this norms red, no, it is basically consisting of an 0 to 30 value. If it is 0 to 30, then that comes under as a norms red, okay, norms master red. Why it will be, no, there will be a lack of excess in this, the production of the gearbox parts. So we need to make sure that before going for child production, these parts should be readily available for smooth production the gearbox. So and also the assembling the gearbox productions. Okay, this is the norms red will tells to the employee. And this is a norms master black. And there I think there is a norms master black, means there is nothing to produce in this gearbox production. So no need to change at all, means no need to produce anything like any child part or any parent part. There is nothing to change, means then we can be marked as like a norms master black. So this is the thing. And also we have like we presented this thing in the ICLTA CAT international conference in the Geetanjali Institute of Science and Technology in Nelluru. And also we get okay, 1 minute. And also we have a patent for this project. The patent yeah, this is the conference conference paper on ICLTA CAT 2025, and the paper is 010 for proof, and we have the conference certificate for this project is like a gearbox using data analytics to increase the efficiency of the gearbox machine shop of this presented on 2nd and 3rd April 2025. And this is the letter of recommendation. So this is a letter of completion of our project in the Ashok Leyland, and we have submitted this project in Ashok Leyland on 15th April 2025. So by using data analytics to increase the efficiency of gearbox machine shop, and also we submitted in this international conference on 2025 on April month. So Dr. Arvind Ayar is my general deputy manager from the Ennore unit project planning division member. And I need to show like the patent work. So we have an patent also on this project. So okay, thank you for this project explanation.